All right, today we're going to be learning about the quadratic formula. This is something you already saw in Algebra 1, so it is not completely new. So hopefully it'll be more of a review. Our objective today says, today we will learn what the quadratic formula is and how to use it to find the roots of a quadratic function. So we're going to start by finding the root of this quadratic function here that is shown, okay, by factoring. So we've already done factoring. If you remember, if there's nothing in front of the x here, there's a 1. And to factor it, we would, if it does start with a 1, then we list the numbers that multiply to give me a 6, or the factors of 6. Okay, it's just 1 and 6 and 3 and 2. And then I pick the one that would add or subtract to give me the middle term, and the middle term is 5. So we know it's going to be 2 and 3 because 2 times 3 will give me 6, but 2 plus 3 will give me 5. Okay. And then everything is positive in my quadratic function, so just plus. So there it is. Those are the factors. If I want to find the roots of the quadratic function that is given to us, once I find the factors, I would set each one to 0 and solve for x. Or the shortcut here is just figure out what would make this inside go to 0. Okay, so obviously it would be -2, because -2 plus 1 plus 2 is 0. And then over here would be -3. But when I mean solve for x, I mean just get the factor, set it equal to 0, solve, so -3 minus 3, 0 minus 3 is -3. Okay, so that's how you find the roots again, or just figure out what value of x will make the parentheses, what's inside the parentheses, go to 0. So the other one would be -2. So those are the two roots. What does it mean is that if I graph this quadratic function, it will cross the x-axis at, oops, that's definitely not what it's going to look like. It would cross the x-axis at -2. Let's see, this is -2 and -3. Well, that's the worst graph ever, but something like that. All right. Okay. Now, what we're going to learn today is how to find the same thing, but not by factoring. We're going to use the quadratic function. Now, the reason why we use the quadratic function is that not every quadratic equation can be factored. Okay. So let's go ahead and take a look at this. Okay, so in order for us to use it, it has to be in standard form. You guys remember standard form? Where all the terms are on the same side. Our highest exponent is 2, and then they follow. The next one is just, the first one is x squared, the next one is x, and the last one on that same side has no variable. As long as they're in this order, we can use a quadratic formula. It is going to be very, very important to identify the A. Okay, whatever the A is, if this would let me draw. Oh, there it is, sorry. A. Okay, because that's going to have a specific spot in the quadratic formula. Then we have to identify the B. The B is the one that's just with the regular x. The one with the x squared is the A. The one with the x is your B. Okay, and the one that does not have a variable at all, that's going to be your C, as long as all the three terms are on the same side of the equals. Okay. So let's do the same problem we did at the beginning by factoring using the quadratic formula. So I'm going to copy it here so you guys can see it. Okay, x squared x equals -b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. Okay. So again, there's nothing in front of my x squared, that's my a. So here you notice that there's an a here next to the 4, and there's an a here next to the 2. So I'm going to go ahead and substitute that value in. So let's see, this is going to be -b plus or minus square root b squared minus 4. And then I'm not going to put a anymore. I'm going to substitute. So I'm going to use parentheses. And wherever a is, I'm going to plug in a 1, right? Because that's what our a is in this problem that we're trying to find the roots. Then we're going to use the b. The b is going to be 5 here, right? That's the next number next to the x. And that's going to go here and here. So what I'm going to do is I'm going to substitute in place of b. So I'm going to erase it there. Be very careful. That's squared for the b. That has to be there. Okay. So that's squared here. Make sure you don't get rid of it. It has to be in there. And then the last number I have here is the 6. The 6 is my c. So that's going to be here. And that's it. There's only one spot for the c. So I'm going to delete that c and I'm going to plug in that 6. Okay. Then we're going to do the math. Okay. And I know this looks ugly, but you actually did the hardest part already. We've done it. It's substituting. After that, it's not that bad. Okay. There's a plus minus here. There's a square root, and we all know how to use the square root. And then we're going to do the math under here. So 5 squared is 25. 25 minus, and then 4 times 1 is 4, and then 4 times 6 is 24. Okay, all over 2 times 1 is on the bottom, so just 2. Simplify it, and we get negative 5 plus or minus the square root of 1 over 2, right? Well, I hope by now you know what the square root of 1 is. 1 times 1 is 1, so the square root of 1 is 1. So it's going to be negative 5 plus or minus 1 over 2. Now this plus or minus throws a lot of people off. Don't worry. All it is that we're going to rewrite the same equation, but instead of putting plus or minus, we'll only put the plus, and then we're going to do it a second time, and instead of putting the minus, we only put, the plus and minus, we only put the minus. So here I'm only going to put the plus, and down here I'm only going to put the minus. And then we do the math. So that's going to be negative 5 plus 1 is negative 4, right? Because they're different signs, so subtract and keep the sign of the larger one. And negative 4 divided by 2 is negative 2. Over here, though, that's negative 5 minus 1. So same signs, add and keep. So we add them and keep the negative sign. And then negative 6 divided by 2 is negative 3. And there are our roots. Okay. Now, obviously, for this problem, it was easier to factor and find the solutions or the roots this way. Okay. Just for example, like the one we did. But again, we do this because not every quadratic function can be factored. All right. Now, this next part is important. The discriminant. It says, given the quadratic equation, y equals ax squared plus bx plus c, which is our standard form for a quadratic function, the discriminant d equals b squared minus 4ac. Tells the type of root the equation has. Now, this is actually not a new equation. I know it looks like, okay, where the heck are they coming up with that? This comes from the quadratic formula right here. It's what's under the square root in the quadratic formula, which we already know what's under the square root. If we were going to use this problem, well, we end up under the square root here. When we do all the math under here, we get a 1. Well, that's actually going to tell us some information here. It says here, if d is less than 0, meaning if our discriminant is negative, then there is no real roots. There's 2 imaginary roots. And we'll talk about that a little bit later in the week, or maybe next week, depending how far we get. If the discriminant is 0, there is 1 real root. And if the discriminant is greater than 0, meaning positive, then there's going to be 2 real roots. And see how it intersects? Okay. If it never intersects, then there's no root, no solution, no 0. Okay, so there's no real solution. It's imaginary. If it only touches 1, then there's only one x-intercept, so only 1 root, 1 solution. And if it touches twice, then 2. All right, so let's do some examples. Now in class, I might not go over all the examples, but since this is a video of our notes, then I'm going to go through every example. So what I suggest when you're going to do the quadratic formula is always copy the quadratic formula first. Negative b plus or minus square root b squared minus 4 times a times c all over, or all divided by 2 times a. Then identify each problem or each number. So here my a is here, my a is here, and there's nothing in front of the x squared, so my a is a 1. Then my b is going to be 8, so I'm going to substitute an 8 here and an 8 here. And then the last one there, my c is 12. Okay, so a, b, c. And then substitute it into the formula. Now be careful because a lot of people forget that there's a b negative in front of that b. So I'm going to put negative b plus or minus square root of b squared minus 4. And then I'm also going to substitute in for the a, for the c, and then all is going to be above the 2a. This is how I suggest you do it. Wherever there's a variable, you put parentheses, and then you substitute in the values. So again, we said a was 1, so here goes a 1. B is 8, so that's going to go here and here. And C is 12, so that's going to go here. Okay. So just make sure when you copy it, don't forget there's a negative in front of that equation, and then that b squared inside the square root has a square, so don't forget. Then I would focus on the inside first. Okay. So if you can use your calculator, you could just simplify. That's going to be 64, right? Okay, let me just go from left to right. So we have a negative 8. I don't need parentheses there. Plus or minus square root, and then that's going to be 64 minus 4 times 1 is 4, and 4 times 12 is 48. Okay. And then 2 times 1 on the bottom is just 2, so that part's done. And then just keep simplifying what's under the square root or what's under the radical, right? That's what it's called, a radical sign. And then 64 minus 48. So borrow 1, 14, that's 6. Okay, so 16. Okay. And remember that what is under the square root is called the discriminant. And in this case, the discriminant is a positive 16. So again, positive number, we're going to have 2 real roots. And you can tell because it's actually a perfect square number. And the square root of 16, and I hope you know, but if you don't, you can always use your calculator. I believe it does do square roots in your phone or in your computer. The square root of 16 is 4. So I'm going to do negative 8 plus or minus 4 over 2. Now don't forget to split it into 2 equations, one with a plus and one with a minus. So negative 8 plus 4 over 2 and negative 8 minus 4 over 2. So negative 8 plus 4, different signs, we subtract them and keep the sign of the larger one. So negative 4 and then divided by 2, it's going to be negative 2. Oops. So this is one of my roots, x equals negative 2. And then negative 8 minus 4, they're the same sign, so that we add and keep the negative sign. Bring the divided by 2 in the bottom. And negative 12 divided by 2 is negative 6. So those are our 2 roots. And so in our answer choices, it'll say x equals negative 2 and x equals negative 6. Next example. I know that took a while, huh? All right, so I'm going to try and do this one a little bit faster. X, so negative b plus or minus square root b squared minus 4 times a times c all over 2a. So negative b, so I'm going to just put parentheses wherever I'm going to substitute. minus 4 times a times c all over 2a. And then in front of the a squared, there's x squared, there's nothing, so it's a 1. Oops. So 1 goes here and here. The b, again, there's actually nothing in front of this x squared. So, I mean, this regular x, so it's also a 1. And then the c is going to be -4, so -4. All right, then we do the math inside. So -1 plus or minus the square root. 1 squared is 1, and then minus 4 times 1 is 4, times -4 is going to be -16. But since I already have a negative here, that's going to be positive 16. Right, -4 times -4 will be positive 16. 2 times 1 is 2. 1 plus or minus, and that's going to be the square root of 17. Wow. Okay. All right, guys. Now, because the discriminant is positive, okay, we're going to have 2 real roots, but they're not going to be pretty. They're going to be some ugly decimals. So you can kind of estimate if you want. For today's assignment, I'd rather you just leave it like this because this number right here cannot be factored. It cannot be square rooted. It's not a perfect square number. So for this assignment, I want you to stop right there, and this is going to be our answer. Okay. Maybe for another assignment, I might ask you to estimate. Like the square root of 16 we know is 4, and then the next number up would be 25. So it would just be like 4.2 or something. Or we could just use a calculator. But for now, this is as far as I want you to go if it cannot be square rooted. Right, next problem. Again, always, I recommend you start by writing the quadratic formula, and you're just going to end up memorizing it after so many times. But your parentheses where we're going to substitute, which is almost the whole thing, and then substitute. So our A here is 2. Our B here is a -1. And then our C is a -7. Okay. So let's do a little bit of math. So careful on this first one, we have a -1, so that's going to be +1. Plus or minus the square root of 1 squared is 1. And then 4 times 2 is 8. And 8 times 7, -7 is going to be -56, but this is a -4, so it's going to end up being a +56. And 2 times 2 is 4. Then we're going to have 1 plus or minus 57. So again, that cannot be factored, square rooted, 57. So that's as far as we go for this assignment. All right. Now, careful, because I know in your assignment, they might not show this problem like this. They might show it like this maybe, where the 7 is on the other side and opposite sign. So make sure that you bring it to the left and change its sign. Okay, make sure all 3 terms are on the same side, and so it's in standard form. All right, last one is a word problem. It says David kicked a ball into the air. The function of the height of the ball is in feet is h equals -16t squared plus 8t, where t represents the time in seconds after the ball is thrown. How long was the ball in the air? Okay, so pretty much it wants to know how long it was in the air and then hits the ground again. So if you actually graph it, it looks something like this, right? When you're throwing a ball and you're starting from the ground, something like that. So it's a quadratic equation. If you weren't sure, obviously it has a square here. So if we want to use the quadratic formula, we can. Just be careful because there's no C. This is going to be our A, this is going to be our B, but see how there's no term, no number without a variable? So there's no C, or the C actually is 0. So just heads up on that. So I'm going to do -b plus or minus square root b squared minus 4ac all over 2a. And I'm going to substitute in my values. for every variable. Okay. So our A here, and they're going to be kind of big numbers, so I'm probably going to end up using a calculator, is 16, 16. Ooh, negative 16, very important. And then my B is 80, so 80, ugh, these going to be big numbers. And then the C, no C, so the C is 0, which is important too, okay? You just can't get rid of it. So I'm going to pull out my phone here so I can use a calculator. So we're going to start with, well, this first one is just negative 80. So negative 80. Plus or minus 80 squared. Well, 80 times 80, 8 times 8 is 64, and then 2 zeros, so 2 zeros. Minus, and it's going to be 4 times negative 16, which is going to make my answer negative, but then times 0, which is just going to make this 0, so 0. Oh, that was easier than I thought. And then 2 times negative 16, which is just 32, so negative 32. Huh, maybe I didn't need the calculator after all. Okay, so obviously this is going to be just negative 80 plus or minus the square root of 64. And we know the square root of 64 is 80. Okay, so we're going to end up having two answers, right? One with plus, one with minus, because we ended up with a positive number inside. So plus, minus. So negative 80 plus 80 divided by 32, negative 32. And then negative 80 minus 80. Ugh. Divided by 30, negative 32. Okay. Well, this one up here is going to be easy because we're going to end up with 0 over 32, negative 32, which anything, 0 divided by anything is 0. So our answer there is 0. And then here, negative 80 minus negative 80 is going to be negative 160. And then we're going to divide by a negative 32, which you would think would come out an ugly number, but nope, it's a positive 5. Okay, so what does that mean? And it makes sense that our answers are nice and neat and positive. Well, mostly that they're positive. But what does it mean? You have two roots. It means that our quadratic function started at 0, because that's our first root, and then it ended at 5. So then what is our answer? Well, we have here x equals, but really our x is t. So t equals, or time equals, 5. 5 what? It was time in seconds, so 5 seconds. So in 5 seconds, the ball will hit the ground, or the ball was in the air 5 seconds, and then it hits the ground. All right, that's it. Your assignment is posted.